Hello learners, I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. Today we are going to discuss about the cracks in concrete beams. As you remember, we have discussed till now about defects in buildings, in which we discussed about defects in timber, in steel, and also defects in sanitary fittings and plumbing. Then later on we move to repairing materials for defects in timber, then for defects in steel, for defects in sanitary fittings and plumbing. We discussed about the repairing materials for miscellaneous defects. Then we discussed about repair and preventive maintenance techniques, in which we discussed about repairing of floors, then strengthening of stone and masonry structures, and lastly we discussed about water and damp proofing. Now we are moving to a new topic, which is strengthening of cracked beams. Today we will be discussing about the causes for defects in beam and structures, particularly concrete structures we are talking about, the types of cracks in concrete beams and repair of concrete structures. Objective of this lecture are as follows: that at the end of this module you should be able to explain the factors contributing to the failure of beams, and also you should be able to describe various types of failure. Now let's begin with the essential conditions for continued serviceability of a structure. That if a building has to be serviceable, what should be its characteristics? Let us start with the essential conditions for continued serviceability of a structure. Means if a building has to be serviceable through its life, then what should be the characteristics or conditions there? First, the mechanical properties of the materials used do not reduce with time to unacceptable levels. Means we know that there is certainly a reduction in the properties of the material, but that should be within the limits. So it should not be up to an unacceptable level. Second is, there is no reduction in size of a structural member, either by erosion of concrete or by spalling or corrosion. That due to the erosion or spalling or corrosion, the size of the structural member should not reduce. Size of the structural member should remain same if the structure has to be serviceable. Next is, there is no significant loss of section of reinforcing steel in concrete. That due to corrosion, the section of the steel should not reduce. Means the size of the reinforcing steel should not reduce. Next is, continuity of structural action is not affected by excessive cracking. That the main structural action should not be affected. So these are the four conditions here for continued serviceability of a structure. Now we move to causes for defects in structures in general and beams in particular. First is that structural deficiency resulting from errors in design, loading criteria, unexpected overloadings, etc. This may be the cause for defect. Next is structural deficiency due to construction defects. That due to faulty construction, there may be deficiency in the structure. Next is damage due to fire, floods, earthquake, cyclones. So due to these natural phenomena or some accidents, damage will be there in the structure. Then damage due to chemical attack. It may be due to environmental conditions, it may be due to industrial activities, or it may be accident. Then damage due to marine environment, because as you know that marine environment is very adverse to the structure. It affects concrete and steel both. Damage due to abrasion of granular materials. You know that due to abrasion of the granular materials, there will be damage to the structure. Then movement of concrete due to physical characteristics. The changes in the characteristics of the concrete due to various factors. So that will be taken care of here, and it may cause defects in the structures. Now let's move to structural deficiency due to design and detailing. So in this case, the design is required to be reviewed in detail and remedial measures worked out by the design team. That if there is some deficiency due to design and detailing, then there is no other option that first it has to be reviewed. Whatever drawbacks are there, what are problems are there in the design, that has to be identified and it has to be redesigned. The structural members have to be redesigned to the correct size so that they can take up the loads or transfer the loads properly. Once this is done, the methods of carrying out the remedial measures will be similar to those arising out of other defects. That whatever you will do or whatever way you will do to correct the problems or rectify the problems of the structure, in other cases, in other defects, similar way this problem will be handled. Then structural deficiency due to construction defects. That there may be defects due to the faulty construction. Defective construction methods form the largest segment of source of distress to the structures. Such defects can be broadly subdivided as follows. What are these? These are defects due to the quality of raw materials first. Second is non-adoption of designed concrete mix. Means we are using the concrete mix which is not designed. Then use of defective construction plant for producing, transporting and placing the concrete. There may be problems during producing the concrete, during transportation of the concrete and also during the placing of concrete. If mistakes are made there, so the defects are bound to come in the structure file. Then very important thing, defective workmanship. That if the tradesmen are not working properly or in a proper way, then certainly it will result a defective construction. Then inadequate quality detailing. That detailing is not proper to achieve the quality construction. Due to this, there will be a structural deficiency in the structure. There will be defects in the structure. So first we have to deal with the materials. So how to choose the material? So choice of materials is very important. As far as the concrete is concerned, you know the ingredients are cement, aggregate, water. So we have to be very careful while selecting the materials. So let us begin with the cement. You know that ordinary Portland cement is commonly used for concrete in normal conditions. Where the concrete is exposed to aggressive environment, it may be necessary to use special cements depending upon the situation, such as sulfate resistant Portland cement, blast furnace slag cement, low C3A cement, low heat cement. So depending upon the situation where the cement is to be used, like in oil wells, we have to use oil well cement. So that way, depending upon the situation, we have to use that particular type of cement which fits the situation. The next is aggregate. Quality of aggregate, particularly in respect of alkali aggregate reaction, needs to be taken into account. Fortunately, cases of defects and failures attributed to alkali aggregate reactions are very rare. A reasonable continuity of grading of aggregates should be ensured for producing quality concrete. Now next is water. So we all have read that water should be of the quality that if we can drink that water is fit for producing concrete. So the use of water containing salts and other impurities for making concrete can also contribute to deterioration of the concrete. Excessive use of water in concrete mix is the largest single source of weakness. Because excessive water is there, so many problems will be created, like bleeding of concrete. And then on evaporation, the pores will be created in the concrete, so which will cause many defects in the concrete. Then measurement of ingredients. This is also very important as far as the quality of concrete is concerned. The accuracy of weighing various components is very much dependent on the quality of the weigh batching system available. Spring-loaded dials of weigh batchers contribute towards excessive variability in quality of weigh batched concrete. Because if there is a variation in the performance of the weigh batchers, then certainly the quality of concrete will vary. If you are not measuring exact amount of the material which is required, then certainly it is going to affect the quality of the concrete. Let's see other contributing factors that add to bad workmanship. These are segregation, improper placement, inadequate or excessive vibration, leakage of mortar through shuttering joints, then inadequate concrete cover, then insufficient curing. So these are some other factors that may add to the bad workmanship. Now let's see other factors leading to poor design detailing. These factors are re-entrant corners, abrupt changes in section, then inadequate joint detailing, deflection limits. If crossed, then there is a problem. Poorly detailed drips and scuppers, then inadequate or improper drainage, then poor detailing of expansion joints. These are some of the factors which may lead to poor design detailing. Bad detailing results in congestion of reinforcement to such an extent that concrete just cannot be placed and compacted properly even if the concrete is workable. So we have to be careful that while placing the reinforcement, while detailing the reinforcement, that it should not result in the congestion of the reinforcement. Now we move to type of cracks in concrete beams. First we begin with analysis of cracks. And in this analysis of cracks, crack width is very important factor. The tensile stresses, though small, can cause cracks, and especially when the span is 4 to 5 meter long. These cracks are harmless for serviceability, durability and safety of the structures as long as the crack width remain under a specified amount, say 0.2 to 0.4 mm, depending upon environmental conditions. This factor is very important that if environmental conditions are different, then the small crack width may be very detrimental actually. Tanks, vessels, sea structures or other containers of liquids or gases need special care because there should not be any leakage due to cracks. Cracks up to a width of 0.4 mm at surface do not increase corrosion if the concrete cover is at least 25 mm for bars smaller than 20 mm. Wider cracks indicate, in most cases, poor detailing of reinforcement and improper bond between reinforcement and concrete. Hence, crack width control is important in addition to appearance and corrosion protection. Basically, cracks develop in concrete because of tensile stresses due to internal and external restraint produced by variation in temperature and shrinkage, etc. In early age, say 3 days of the structure, the tensile strength of concrete is still very low, and the tensile stresses due to temperature differentials caused by heat of hydration easily rise above the strength of the concrete and cause cracks. Micro cracks between coarse aggregate and mortar are formed at early age, which reduces the final tensile strength of concrete. There are secondary tensile stresses produced in concrete at various points for which we need some amount of tensile stresses in concrete. For example, the splitting stress due to bond with deformed bars. Also, after hardening of the concrete, tensile stresses due to restraint, that is because of temperature and shrinkage, etc., can even exceed the tensile strength of good concrete. Cracks cannot be prevented by reinforcement. Proper reinforcement can only prevent the opening of cracks and can enforce small crack widths. Means the proper reinforcement will prevent the opening of cracks and it will enforce that cracks are small. Width of crack is small. A crack width at surface of 0.3 mm may correspond to 0.1 to 0.05 mm width at the bar surface. Means here you see that the crack having width 0.3 mm will be having a smaller crack width at the reinforcing bar level. You can see here, depending upon cover and the bar size. Hence, the effect on corrosion is small or negligible. Crack width also increases with the distance transfers to the bar of the point of crack width measurement. Hence, if appearance is not important, from corrosion consideration, the crack width at the crossing of the bar counts. The admissible amount depends on the cover, which should be related to the bar diameter, say twice the bar diameter for humid corrosive environment. Should be protected by a small transverse reinforcement. The crack width theories developed are for flexural cases, may be combined with axial forces, and where the crack is perpendicular to the reinforcing bar, that is transverse cracks. However, cracks just above the reinforcing bars and parallel to the bar, that is longitudinal cracks, are more dangerous because of loss of bond and very high susceptibility of corrosion of reinforcement. Now let's see different type of cracks. So first is separation crack. Members subjected to axial tension may have crack spread over entire cross-sectional area of the member. Similar cracks may be formed in the web of the beam of sizable depth due to shear or failure. So you see here the separation crack. Next is flexural crack. A concrete member in bending will develop flexural cracks which start from tensile phase and end up near the neutral axis. You can see the flexural cracks in the beam shown here, which are starting from the bottom, means the tensile phase, and they are ending up near the neutral axis. Next is forking cracks. A beam of depth more than 750 mm and heavily reinforced on tension side under a bending movement will develop closely spaced crack on tension phase, which tend to join to web cracks with a larger space. Such cracks are called forking cracks. Forking cracks may have large crack width because of larger crack spacing, more so when longitudinal steel in web is absent. Here you see flexural cracks. There are two situations. One is under bending and second one under tension. In two different situations you see here the flexural crack. In slabs, between the flexural cracks, smaller cracks are developed which do not extend up to neutral axis. There may be more internal bond cracks starting from the deformations on the surface of bars, which are usually quite small cracks. So here you see the cracks in the slab. Next is shear crack. Shear cracks are inclined to the axis of beam between 25 degree to 50 degree. Shear crack may begin as the flexural cracks from the tension phase of the beam, or these may be only in web and these are caused by shear force. Torsion also causes inclined cracks, but on all faces of prismatic member. This is the difference between the cracks caused by torsion and cracks caused by the shear. So here you see the shear cracks. Next is surface crack. Surface cracks are harmless type. These are in random direction and these are usually not deep. These are due to surface shrinkage and are prominent when high quantity of cement, water and fine aggregates are used. Here you see the surface cracks in the structure. Next is longitudinal crack. Longitudinal cracks are dangerous type of cracks and these are along the bar caused by settlement of deep fresh concrete. These are because of poor wall. This type will usually be found above thick bars if concrete has too much slump and was rather deep. Similar longitudinal cracks are also formed by splitting force due to bond stress in deformed bars. Next is micro cracks. Micro cracks are very small cracks, as it is clear from their name, micro. These may be in the interior of the concrete. These have no relevance to crack width limitation. So in this lecture we discussed about the causes of defects in structures in general and in beams particular, in which we discussed about structural deficiency due to design and detailing, then structural deficiency due to construction defects, then we discuss about analysis of cracks, and then finally we discuss about types of cracks. In the next lecture we will discuss about the repair of concrete structures, in which we will discuss about the materials for repair as well as techniques for repair. So you go through the text to enrich your knowledge. We will meet in the next lecture. Thank you.